Hi everyone, welcome to our new video today. We will continue from the previous lesson by click to File. We start from New Frame, or you can type L plus number 1 in your keyboard. When I click on Frame, there will be a new display, New Frame. We can start from setting the number of span or frame that you want. For example, if I only want 2 span of frame, I can just click 2 frame. If I want to increase, I can increase to up to multiple span of frame. But at this moment, we will try with only 2 span of frame. Below this, you see the option cantilever left. If you want your left span to have a cantilever, you can check left cantilever. If not, you can uncheck it. At the same time, if you want the right cantilever, you can check right. If not, you can uncheck this. And then you can see that there is another option that allows you to select whether you want to design a reinforced concrete frame or pre-stressed frame. If you are going to design the RC frame, you don't need to check this one. If you need PT or pre-stressed frame, you can check on this box. Okay. On the right side, you will see that there is a panel type for you to select: internal panel or external panel. Internal panel refer to the one of the panel that you selected not at the edge of the building. External refer to the panel type that's situated or located at the edge of the building. For this example, I select the internal panel. Below this, there is a list of building type ranging from domestic, office, parking, retail, storage, roof assembly, or heavy traffic. For the example, I'm going to choose office. And then you can go to loading type. Under this list, there is a general loading type, masonry partition, brittle finish, vehicle, and transfer. Simply, I will just select general. For the structural system below, there is a general, flat plate, flat slab, one-way slab wall, one-way slab beam, one-way slab band, one-way beam slab, two-way beam slab, two-way band slab. For example, if you select a flat slab, the other option below this will be activated for you to key in any number that you want. If you select flat slab, the option drop panel will be activated. If you select the two-way beam slab, and then the other option will be activated depend on the type of structural system that you are going to select. If I select general, all of these cannot be activated, but you can edit it in the next step. It doesn't matter, even though now this option is still not activated. I can just click OK. Now the software brings us to a new display. We can see that in the menu there is a File, Edit, View, Tool, Report, Window, and Help. This is more than what we have earlier. Under the File, we have a New, Open, Save As, Export. Export. You can export your tenant profile into DXF file. For example, you can print your report. Edit, you can undo or redo, cut or paste or copy. View, you see the status bar. If we uncheck this one, the status bar will not be displayed. When we check this one, the status bar below is displayed. Next one is window bar. When you check this window bar, another window toolbar will be displayed. cascade window, tile window, close all window, arrange window. You can also have hide and show tree. If you click on this, one of the show tree option will not be displayed. If you want to get it back, you go to view and then you click it. So this show tree will come back. Also, you can select the user preference similar to what we have discussed together in our previous video. Next one, there is a tool. You can either repeat without confirm, check logic, suppress error report, or save as user-defined unit format. We will go into this function later once we do the example. Next one is the report. You can create the report, clear all the report, set to save format, set page start number, or calculate. Under the window, there is the same. Have, there is a content similar to what we discussed earlier as well. This is new. You can create a new file from here, open existing file, save, cut, copy, print preview, item specific help. If you need some help, you can click and search for any specific help that you want. Check logic. Check logic refers to before you do any analysis or calculation, you can ask software to check any logic regarding your input to verify that you have already input all of the hypotheses. Whether it is logic or not, software will give you a warning message. Show message window. If there are some warning or error, it will display the message window. Calculate result. When your model logic has been checked, there is no error, you can go into the calculate result. For the first time, we can start our input from general. At the right hand side, there is a tab designer. So you can write your own name. For example, we can start with engineer, project name, post tension, project number 1. Frame description, you can just leave it blank or you want to describe something. For example, I write HPT beam, for example, and then I can put 1 for beam label. You see that there is a symbol here, AA, meaning that at this tab you can write or type any text that you want. Next one is the design code. From design code to the concrete column, there is another symbol. From this, there is a list that you can select. By default, we have selected Singapore Eurocode 2 for the design code. Hence, at this moment, Singapore Eurocode is already here. Material, we also select as default Singapore Eurocode material. Reinforcement type, there is 3 options. First is reinforced concrete. Second is bound pre-stressed concrete. Third, unbound post tension. For this example, since we are looking for bound pre-stress, we can click on bound pre-stress. Once you click on bound pre-stress, you will notice that this tab of pre-stress is activated. If we change this bound pre-stress to reinforce, meaning that we are going to analyze the reinforced concrete. There is no pre-stressed tape here. Member type. There is two options, whether you are going to design slab or beam. If we click slab, by default, all the information here, we have the span, column, drop panel. Once we change from slab to beam, you will notice that the option beam is activated for you to input the beam dimension. Next one, there is a panel type. Under the panel type, as we selected earlier, we select the internal, meaning that we choose the internal panel type to design. Strip type. Below this, there are 4 options of strip type that the user can select. For example, one-way nominal width. Next one is one-way full width. For beam design, one-way full width is not available. There is only one-way nominal width. You can notice that one-way full width under beam, there is a red rectangular around the one-way full width, which indicate that this option cannot work with the beam. If I change this to slab, we have one-way nominal width and one-way full width. One-way nominal width and full width can work both for slab except beam. If we select two-way slab is also available. Two-way average is not available for slab. If we choose two-way and then we change to beam, next we try two-way average. This also cannot work with the beam. In this example, we will start with one-way nominal width. Don't worry, this is a bit frustrated for engineer. Sometimes we do not know whether we are going to choose one-way nominal width or one-way full width. Which one is logic to our design case? In next video, we will briefly some of the concept when that we can use one-way nominal width, when we use one-way full width, two-way or two-way average. What RAPT software we consider when the user select different strip type. Next one is column stiffness. Under the column stiffness, there is equivalent column, net column, and enhanced column stiffness. RAPT software suggests engineer to use the equivalent column. Concrete type. There is a standard concrete type. For spanning member, you can select a list of concrete strength available in the material under each preferred design code. For this beam, we will start with concrete C3240. Concrete column also C3240. Top reinforcement cover we keep default 40 mm. Bottom reinforcement cover 40 mm. Top reinforcement axis step limit and bottom reinforcement axis step limit 30 by default. Concrete unit weight 25 by default. Savage definition, we allow program to automatically calculate the savage and consider it into the analysis. Pattern light load, we recommend to allow the pattern light load for the analysis. Earthquake is not considered here. Moment distribution 0. Depend on each design code and whether you want to redistribute how many percent of moment. You can change the moment distribution here, for example 10%. Design surface level, there is extreme surface and reduced level. For ease of working in the example, we prefer to use extreme surface. It depends on the designer choice and practice in their own region whether the reduced level is preferred or extreme surface is preferred. Eurocode ultimate load combination basis is equation 610 under Eurocode. This is a brief input for the general. Next, we will see in detail what is the definition of panel type, strip type, and column stiffness. When should we select each option for our analysis? Next, we will see some detailed information in addition to the explanation earlier. For member type, the user can select either slab or beam. Once we select the beam, there will be the display of beam option will be available. For panel type, they are having the internal and external. If the user selects the internal, meaning that the slab will extend on both sides of the column to another support line on both sides. For external, slab will extend only to another support line on one side of the frame, with another side being a free edge. For example, as the illustration below, here is the external strip. Once the external panel type is selected, the user can define the edge of the slab to some extent that we are looking for. For example, if we select this as the external width, we go to the span. The display of external edge distance left and external edge distance right is available for user to input. On the other hand, if we choose the word internal, we go back to the span, the external edge option is disappear from here. So here we can understand that when we choose the internal or external, it affects our input regarding the slab edge. After this, it is the strip type. In strip type, there are one-way nominal width, one-way full width, two-way, and two-way average. If the user select one-way nominal width, this option can be applied to the slab system and beam system. For slab system, the definition will be defined by considering a 1 meter strip panel as a one-way spanning slab. For beam design, if selected one-way nominal width, the software will design the effective beam to support the full panel load. There is no transverse distribution of moment. Salvage and panel load are calculated for panel width. Point load are applied to the effective beam. If one-way full width is selected, slab system is available, but beam system is not applicable for one-way full width. Slab system design the full panel width of the defined slab. The design width is the panel width at all locations. There is no transverse distribution of moment, used typically for slab spanning between beam and slab spanning across the wall. Salvage and panel load are calculated for the full slab width. Point load are applied to the full slab width. There is no limitation on the use of step and temper to the surface. For two-way, the design will be considered the slab into column strip and middle strip. Moment and shear force are distributed to this strip using the standard distribution factor as defined in each design code. Last option, there is two-way average. This allows in the ACI 31H for designing a two-way preset slab. However, this method is not allowed in the AS3600. After this, we can go into the column stiffness information. RAPT allows user to choose to model the frame run based on 3 different stiffness approach. First is the equivalent column approach. This approach takes into account the infinite stiffness of the slab beam at the column interface. This is the default and should be used for most slab beam in the building floor system. Second, net column stiffness. The basic column stiffness. There is no attempt is made to allow for torsional rotation of the slab at the column to the effect of the slab beam at the column interface. 3. Enhanced column stiffness. The stiffness of the column take into account the infinite stiffness of the slab beam at the column interface. This option should only be used for concrete portal frame, where there is no transverse torsional member. In the equivalent column approach, it requires frame action, a sub-beam column system having a rigid joint, and a composite action between slab and beam. If net column stiffness is selected, the program will calculate for the stiffness of the rectangular column or circular column based on the formula below. If the enhanced column stiffness is selected, the software will calculate the column stiffness based on alternative formula. Next one is the moment distribution. For moment distribution, designer can define a percentage of moment to be redistributed. RAPT will distribute the ultimate moment and ultimate associated shear force for the ultimate design strength calculation. However, serviceability load combination remain unaffected. There are some differences between the applied code for the moment distribution. For example, in ACI 31H, 15% of distribution will be allowed. However, for Eurocode 2, 3% is allowed for Class B or Class C reinforcement, whereas 20% for Class A reinforcement. Next one is design surface level. Under design surface level, user can either select the reuse surface or the extreme surface. Designer can request the software to use one of the following methods to define the concrete surface level. If the reuse surface is selected, the software will use the minimum depth of the relevant surface to the reuse surface of the cross-section. However, if the extreme surface is selected, the software will select the extreme concrete surface over the full width of the design strip of the relevant surface, meaning the top reference level for the column strip and middle strip will be used for the design definition.